Hi, in this video, I'm going to teach you how to simplify algebraic fractions. So uh, in arithmetic, we also combine fractions in algebra. Okay, the rules in addition, subtraction, multiplication, and division of fractions in arithmetic is really similar to how we work on algebraic expressions. Okay, so just a quick review on how to combine fractions. It is very easy to combine fractions when they have the same denominators, like 1 7 plus 3 7 is 4 sevens. Okay, so in an algorithmic understanding, we just add 1 and 3 and we copy the denominator 7. Or in a more conceptual manner, if you have like 1 2 3 4 5 6, that's 1 2 3 4 5 6 7. Then let's say I have 1 2 3 4 5 6, and then that's 7. If I have 1 7, then we have to add 3 sevens. So this is 1 7 plus 3 7, and that means 1 2 3 4, so the sum is 4 sevens. Okay, so but the case is different when you add fractions with denominators that are not the same. So for example, if I want to add 1/3 and 1/4, then I have to use what we call the LCD. The LCD is the least common multiple of the denominators. Now, some people can easily spot the LCD of 3 and 4 as 12, but if you are not sure on how to get the LCD, getting the LCD is like counting by 3 and by 4 in this example, and the first number that will be the same will be the LCD. So like 3, 6, 9, 12, and then 15, and then you can continue counting if you want, but you can limit it for a few numbers first. Then you have 4, 8, 12, and then 16. But before you continue, you should have noticed that there's already a number that is the same after counting by 3 and by 4, and that is 12. So the LCD of these two fractions is 12. Okay, so we have 12, or the LCM of 3 and 4. So in using the LCD, so you want to make this over 12 and over 12. My personal technique in making the denominators the same is I have to think of a number to multiply to 3 to make it 12, so that must be 4. So to keep the fraction the same, I should multiply the numerator also by 4. Then to make the second fraction over 12, I have to multiply 4 by 3, and to keep the fraction the same, I should multiply 1 by 3. So that means 4 and 3 is 12, 4 and 3 is 12, but the numerators will now be 4, which is 4 times 1, and 3, which is 1 times 3. And the moment the denominators are the same, we can apply the basic rule on adding fractions. So we just have to add the numerators. So 4 and 3 is 7, and then we copy the denominator 12. Okay, so these rules will apply also for subtraction. Okay, so you can explore more examples on that. Okay, so now that we have the basic idea, we we had a refresher on how to combine fractions. I hope you will see that adding algebraic fractions could also be done easily. Okay, so let's take some examples. So example 1. Suppose I want to add x over 3 and 2x over 4. Okay, so you can think of this as 1/3 x and 2/4 of x. Okay, so that's another way of writing x over 3 plus 2x over 4. It's 1/3 x plus 2/4 x. So you're basically adding these two, but they don't have the same denominator, so we have to work on with the LCD. And since we have seen this in the previous discussion, the LCD of 3 and 4 is 12. So I'll make the denominators 12, and that would mean 3 should be multiplied by 4, and to maintain the balance, the numerator also be multiplied by 4. So it's 4 times 1, so it's 4, but we're working with algebraic expressions in which the variable is x. So we have 4, 12x, and then add now. So this 4, to become 12, we should multiply by 3, so the numerator should also be multiplied by 3. So you have 6 and then the x. Then after that, just combine the two fractions. Okay, so we have 4, 12 plus 6 over 12 is 10. So that's 10 over 12 and then x. Now you can also write this in simplest form. So 10 over 12 is 5 over 6x, which is also the same as 5x over 6. So you see, adding algebraic expressions is like working with simple fractions. Okay, so even if you have x there, you try to look at them as simple fractions and then just add them naturally. Okay, let's take a look at a more complex example. So let's have example number 2. Suppose we have 3p minus 2q over 5 plus 4p minus 5q over 10. So if we look at them, this is one fraction and this is another fraction, but they don't have the same denominator, so we cannot just add them directly. So what we can do is we use the LCD, and the LCD is 10. Okay, so this is already 10, so there is nothing for us to do to 4p and minus 5q. But for the 5, to make this 10, we have to multiply this by 2. Hence, to keep the fraction the same, the numerator should be multiplied to 2. So this will become 6p by the distributive law, 6p minus 4q now over 10. So plus 4p minus 5q over 10. And addition of algebraic fractions is just the same as addition of simple fractions. So you have over 10, so this will become, the answer will be over 10, and all you have to do is to add the numerators of each fraction. So you have 6p minus 4q and then plus 4p minus 5q, and then just try to add the numerators. 6p and 4p is 10p, while negative 4q and negative 5q will become negative 9q or minus 9q, so over 10. So this is the combined expression for 6p minus 4q over 10 plus 4p minus 5q over 10, which came from the given expression at the beginning. Okay, so those are just two examples, but I hope you somehow learn how to add algebraic fractions. So try to make more videos to show more examples, but for now, so let's just focus on the basic idea and on the examples that I have given to you. So this is simplifying algebraic fractions. Okay, that's it.